right, in question 8 from last year's final, we're taking a look at the function sine x over the interval from 0 to pi, and we're going to be approximating the integral from 0 to pi of sine x dx using a Riemann sum. In fact, we're told to use a lower sum with 4 rectangles. We're using a regular partition. That just means that we're chopping this interval into 4 equal pieces so that the base of all the rectangles will be the same. Okay, so the first thing we're asked to do is just sketch this function from 0 to pi. There we have it. That's one bump on the sine curve. Okay. Now, if we're going to chop the interval up into 4 pieces, here's from 0 to pi. If I chop it up into 4 pieces, my endpoints are just going to be pi over 4, pi over 2, 3 pi over 4. So 0 is my starting point, then pi over 4, pi over 2, 3 pi over 4, and pi. My delta x is just the length of the interval, which is pi minus 0. Of course, that's just pi, but I like to remind myself that I calculate the length as the right endpoint minus the left endpoint, so that I don't, if I'm suddenly not starting at 0, just accidentally plug in the right endpoint for the length, divided by 4, so it's just pi over 4. So those are our endpoints, so I can mark that off here. So here's pi over 2, pi over 4, 3 pi over 4. That chopping of the interval, of course, induces a chopping of the sine graph. Okay. Now, we're taking a lower sum, so I'm going to create a table of values where I just list the x values that we're going to choose, and then the function value, which I could have just written sine x, called it f of x, that's totally fine. If we're doing a lower sum, that means we're always going to pick the x value that corresponds to the smallest y value on that subinterval. So from 0 to pi over 4, the sine function is increasing. The lowest value is going to be at 0, and at 0, of course, sine of 0 is 0. Now, I'm going to sort of do parts 2 and 3 together. Part 2 of the question asks us to come up with this Riemann sum. Part 3 asks us to draw the rectangles that we're using. So for this first rectangle, we've got just a degenerate rectangle with 0 height. Now on the next interval, from pi over 4 to pi over 2, the lowest point is at the left endpoint, because again, the function is still increasing there. So I'm going to choose that as my representative point, treat it as if the height is constant there. So there's my next rectangle. So the x value that I chose was pi over 4, and sine of pi over 4 is root 2 over 2. Now, from pi over 2 to 3 pi over 4, now my function has started to decrease. Okay, and so now the smallest value is going to be on the right side of the curve. So my representative x value will become 3 pi over 4. That's the location of the lowest value on this subinterval. I'll extend my height across there. I just sort of evened out the graph because I recognized that at pi over 4 and at 3 pi over 4, I was going to have the same heights, and I'd drawn this kind of quickly, so it was a little bit out of whack. Okay, so then that's 3 pi over 4, and again, sine of that is root 2 over 2. So I've got these two rectangles that both have a height of root 2 over 2. Then on the fourth subinterval, once again, the function is decreasing, so the lowest value is going to occur at that right endpoint. So my representative x value is going to be pi, and the height at pi is just 0. So I'm getting another degenerate rectangle. So I'm actually getting 2 degenerate rectangles and then 2 non-degenerate rectangles. And I would say the integral from 0 to pi of sine x dx is approximately, okay, this is a pretty bad approximation, as I can see, because I'm missing a lot of area, but it would be approximately, I'm going to just take that pi over 4, that's the common base, I'm going to go ahead and factor it out, and then just multiply it by the sum of these heights. 0 plus root 2 over 2 plus root 2 over 2 plus 0. Notice as I distribute, I'm just getting base times height plus base times height plus base times height plus base times height, so I'm getting these areas. But that works out fairly nicely, so that's going to be pi. This just gives me root 2, because it's 2 halves of root 2, so pi root 2 over 4 would be my Riemann sum, with that as the picture of my rectangle.